Problem 6. I need to find out value of load resistance to get the maximum power from rest of the circuit, and also I need to calculate maximum power at load. I am following maximum power transfer theorem. I need to find out VTH, that is the open circuit voltage. So removing this load, and the potential across this is the open circuit voltage, that is VTH. The rest part is same. To find VOC, ultimately I shall use this loop tree. The summation of this source, potential drop across this 5 and this VOC will be equal to 0. Now to get voltage across this 5 ohm, I need to find current through this 5 ohm resistance. To calculate current through this 5 ohm resistance, I am using this loop and this loop. Say current through this loop in this direction is I1, current through this loop in this direction is I2. Now from first loop, I1 current is flowing through this 20 ohm resistance. So this is positive, this is negative. In 2 ohm resistance, I1 is in this direction and I2 is in this direction. So I1 minus I2 is flowing in downward direction. So polarity is this is positive, this is negative. So I1 into 20, this one, and 2 into I1 minus I2, this 2. Now summation of these 3 in this loop is 0. Now see, this is minus plus, this is plus minus plus minus. These two are in series and this is in series opposition. So if we consider this 20 as positive, this will be negative, this will be negative. So 20 minus this one is equal to 1. From here I got 11 I1 minus I2 is equal to 10. This is equation number 1. Now from loop 2, I2 current is flowing from left to right. So here this is positive, this is negative. I2 current is flowing through this 5 ohm resistance. So this is positive, this is negative. Through 2 ohm resistance, I2 is in upward direction and I1 is in downward direction. So I2 minus I1 is flowing in down to up. So this is positive, this is negative. So see, this is plus minus plus minus plus minus. So summation of these 3 will be equal to 0. So this is 10 into I2, 5 into I2 plus 2 into I2 minus I1 is equal to 0. So ultimately I1 is equal to 8.5 into I2. This is equation 2. Solving this equation 1 and equation 2, I got I2 is equal to 0.108 amperes, which is flowing through this 5 ohm resistance. So what will be voltage across this 5 ohm resistance? This is 5 multiplied by I2, ultimately 0.54 volt. This is this voltage and polarity is positive and negative. Now using KVL in this loop, this is plus minus minus plus minus plus 0.54. So ultimately using KVL here, this VOC minus this 50 minus this one is equal to 0. So ultimately I got VOC is 50.54 voltage. Next, calculating RTH, removing this load. Now looking through these points X and Y, we see that the equivalent resistance I shall get from this resistive network, that is RTH. If it is difficult to understand which one is parallel, which one is in series, then redraw this with a simple one. So I am starting from this X. So say this is X point. Here I got two paths. One is 5 ohm, another one is 10 ohm. So I got one path which is 5, another path which is 10. Here I got again two paths, one is 20, another one is 2, 20, another one is 2. These two resistance meets at a particular point, this one, which again meets another side of 5 ohm. So, and this point is ultimately Y. Now it is very easy to understand that first 20 and 2 are in parallel. It will be in series with 10, and equivalent of this is in parallel with 5. Ultimately, after calculation, I got the value of RTH is 3.5 ohm. So this is equivalent Thevenin circuit. Thevenin voltage is 50.54. Thevenin resistance is 3.5. Now to get the maximum power at load, the load resistance should be equal to this, that is 3.5 ohm. Now putting the value of open circuit voltage, that is VTH, in this equation to get maximum power, I got the maximum power is 182.44 watt. Now checking whether my calculation is perfect or not. This is equivalent circuit. Thevenin resistance 3.5, load resistance should be equal 3.5, and in main circuit I have used load resistance as 3.5. Now if I get power at main circuit and power at equivalent circuit are same, and if it is 182.4 watt, then it can be assured that my calculation is perfect. Now running the simulation. Say in main circuit is 182 watt, in equivalent circuit also it is showing 182 watt. Sort of the calculation I did, that is perfectly okay.